All right. Hello, everyone. Hopefully you can hear us. That's always a better thing when we start a webinar. As always, we'll wait just maybe one or 2 minutes to make sure that that everyone has time to join for their lunch break. But just to make sure that you're at the right place, this will be a Senceive webinar with myself, Arnaud, and Callum Davidson, on the role of wireless technology on UK and European capital projects. So thanks for joining. As I said, let's wait maybe one or two minutes, making sure that everyone joins. We already have a decent crowd. But yeah, just making sure that no one misses too much of our intro. All right, Callum, you doing okay?
Fine, yourself?
Yeah, all good, all good. Let's see. Numbers are still going up. What time is it? 101. Okay. Numbers are still going up a tiny bit. Well, I think we should go. I think a lot of people that might join later might not be interested in our introduction. So let's start with ourselves. Callum, you want to go ahead?
Okay. My name's Callum Davidson. I've been working in the instrumentation and monitoring industry for about 10 years. Spent the last 6 years in the States working for an engineering consultancy firm and an instrumentation and monitoring company, and recently moved over to Senceive at the beginning of the year as business development manager for the UK.
Perfect. Thanks for that, Callum. My name is Arnaud Lancon. I've been working for in the civil engineering industry for the past 10 years or so as well. Started as a civil engineer in Paris with Soletanche Bachy, and then moved to the UK to work on Crossrail for Senceive. And about 5 years ago, I joined Senceive to work first on the business development side of things, on the international side of ththings, and since the beginning of the year, I've started to work as the head of sales operation. I've done quite a lot of webinars before, but yeah, this is the first time we're running this one. So hopefully it is interesting for everyone. But here you have it, and the title is the role of wireless monitoring in strategic UK and European projects. So trying to explain how wireless technology, and especially Senceive wireless technology, can help this large project with examples from the UK and Europe. So let's crack on. If we look at the plan for today, table of content, well, we'll start with a brief intro with the history of the monitoring industry and the trends that we can see through it, both on the general industry side, but also more specific to the Senceive side of things. And then we'll move to concrete examples, as we said. First, from the UK, quite a mature market for monitoring, and to Europe, an evolving market, putting a lot of things in place. But let's start with history and trends. So first of all, where we've been when we look at the industry in general. Well, the bottom line here is that if you look at where we are today, we haven't invented that much. We rely a lot on the things that have been done before us when it comes to theory. If you think about modern geotechnical engineering, well, that was really developed around like 1925. You think about Carl Terzaghi, same thing with structural engineering, that goes all the way back to even like Renaissance. Even if obviously it has evolved all the way to the 1970s with more like computer-based application. But when we look at the theory side, things have been quite stable for a couple of years. John Dunnicliffe said himself, like geotechnical monitoring really came out in the 1930s, 1940s. And when we look at the technology side of things, when it comes to the vibrating wire technology invented by Andre Coyne around like 1931, piezometer, Arthur Casagrande, I think that's 1946, if I remember well. The theodolite around like goes all the way back to 1782 with the grand theodolite. So even if it has evolved, the first total station per se was in the 70s. So again, existing technology. And even if you look at the MEMS technology that Senceive relies on for a lot of our sensors, well, that was invented back in 1965, or at least patented around then. So the bottom line is, well, we are relying on all these amazing things still today. But now let's look at where Senceive comes from. Callum?
Thanks, Arnaud. So Senceive is a spin-off from the University College London, founded back in 2003, and it's from their engineering department. Been developing wireless monitoring solutions that focus primarily on the civil engineering sector and bringing some of the equipment, as Arnaud previously stated, some of the vibrating wire or MEM sensors to the 21st century.
So not as old as the rest of the industry, obviously, but as you can see, quite an early on origin for our company. If we look at where we are now, still as an introduction, now we've tried to focus on from the early 2000s till now, and the main point that we want to make is that from this initial technology, from these initial theories, the main changes has been, well, the automation and the visualization. When it comes to the technology, if you take the example of, as I said, theodolites and more so total stations, or if you take this example of a large project in Amsterdam with Soldata at the time, that was one of the first large deployment of total stations and being put in a large network of 3D measurement. So obviously here, automation of the data coming back to an end user. Same thing when it comes to platforms. For people in the UK, a lot of you will know USIMS and the goal of USIMS on Crossrail, this large project, bringing the data all together from different actors, different partners on a large project. So that is really a trend today, making sure that all the data from different type of instruments, different type of actors can come back together. But one point that we wanted to make was also the rise of Excel. If you work in monitoring or in engineering in general, that's obviously a tool that you're very familiar with. And if you look even today, when you have all these new platforms, all these new systems, a lot of people still rely on this good old Excel spreadsheet. And that's true today. When you look at reporting, when you look at a lot of calculation, it's true that a lot of people still rely on that. So that's the current state of current technology, the industry. Obviously, a very quick overview. There are a lot of things happening, but these were the points that we wanted to highlight in introduction. Now let's look at where Senceive is today.
So it's the same as the industry as a whole, kind of developing into automation and visualization. So from the early sensors developed, we've created a larger portfolio, whether that be, say, tilt meters, automated crack sensors, optical displacement sensors, then also been listening to the civil engineering markets and designing brackets around that, whether that be beams or magnetic mounts. We also have multiple wireless platforms, so point-to-point here, GeoWAN, or a more highly dense flat mesh platform as well.
From the early idea of developing, well, the best wireless platform for any industrial application, yeah, obviously Senceive evolved to finding the best solutions for each and every application on your civil engineering construction projects, which explain why we have so many new development, new sensors, and best adapted to the civil engineering industry. So that's the current state of play. Now, if we look at where we're going as an industry in general, the main points that we want to highlight is first the technology democratization and a little typo here, the collaboration between people and technologies. If you look at different trends that we've seen with our partners, surveyors, engineers, the rise of things like 3D scans, but also LiDAR, obviously, that these are things that are becoming more and more accessible to a lot of projects, small size and medium size, as well as the large projects that we'll present later. But the collaboration means that there is also more work between different people in the industry. Yeah, as we said, surveyors will work with engineers, will work with manufacturers to find the best technology available, and different technologies will be used side by side by experts in their field. If you look at this project with the building collapsing, as I said, 3D scan was used next to wireless technology. Here, vibration and shock technology was used next to tilt and stability technology. On this large project here in Crossrail, obviously, the use of lead and LiDAR was used next to 3D measurements, automated, manual, plus a lot of sensors. So really, that's what we're seeing, and that's what we're trying to embrace as a company, bringing the best technology part of this trend. But on top of that, can explain where we're going as Senceive.
Yeah, thanks. So as Senceive, we're looking to interact and understand the data more with added intelligence to the wireless monitoring system, whether that be faster reporting rates when nodes surpass threshold levels, or integration to cameras. So, for example, on the left here we have a deer that may have triggered one of these tilt meters on the right hand side, and a picture was taken. So there, no change. All we have in the central picture here, a landslide that occurred at Barnhurst, where we have a camera that was a photograph was taken of the landslide. Yes, after nodes reported that it exceeded its thresholds, and that gives us a better understanding of the data on a day-to-day basis.
Yeah, and that explains really how wireless technology can become even more popular, as you can see on the little map right here. Already, Senceive works across most continents and is growing, but that's because on top of having an current existing reliable technology, on top of that, we are bringing to the market these new innovations and possibilities to make your data more reliable and to make your understanding of your site even better, with different new types of sensors and different capabilities of interactions between sensors, self-triggering pictures, increase of reporting rate. So these are the trends that are happening right now within Senceive. So that's it when it comes to the first part, history and trends, sort of setting the pictures for these large projects. And now it's time to look at concrete examples of application for the wireless technology to UK and then Europe projects. So starting with Callum and looking at 3 capital projects in the UK. UK key, which is at this moment at the forefront of safety technology. That's the main theme here. Callum, go ahead.
Yeah, thank you very much. Okay, so we're going to start with the A14 here and see how wireless systems improved safety and data reliability on a remote site. So as you can see here, this is a highways project between the A1 and the M11. It's around 20 miles of road in a very remote setting. It also crossed the Great River Ouse and 4 tracks on the East Coast Main Line.
Yeah, so quite a remote site in the middle of Cambridgeshire.
Yeah. So the challenges for this included obviously its rural location, the access to the East Coast main line that ran through the site on this example picture. The monitoring had to be reliable given the construction was set to take multiple years, and obviously the severity of the UK weather. And then obviously the safety of workers, both on the construction site and on the track, was paramount. So reducing that time spent monitoring the track or people on the construction sites was extremely beneficial.
Yeah, here we can see on the picture in green, like the actual area that needed to be controlled, and obviously like the new viaduct and the new road that was being built across that. So that's that's a setup.
Thanks. Given the remote setting, as stated before, it needed to be precise and reliable. So on the picture here, we have some tilt sensors on the track itself. I believe there was roughly 500 meters of monitoring per track. So there's 4 tracks here. There was monitoring of the catenary poles and monitoring of the abutments being constructed. We also installed backup gateways for redundancy. So if for whatever reason communication couldn't be sent, we had a redundancy backup there, which increased safety because it reduced time spent accessing the site.
Yeah, so that's it's quite good to understand that not only the technology stop people to have to access this busy track too often, but as Callum pointed out, the backup idea of the gateways, always sending back data or potentially saving data on their internal memory, really help to deliver that data on this rural site where we had like quite a difficult access. So that's it for A14. Moving on to the next capital project or large infrastructure project in the UK with the Network Rail Earthworks.
Yeah. Okay, so with Network Rail, we needed to provide monitoring solutions for an aging infrastructure. So as stated here, there's about 190,000 earthwork assets within Network Rail across 20,000 miles of track in the UK. The majority of these earthworks, whether they be embankments, soil cuttings or rock cuttings, were built over 150 years ago and are coming to the end of their life. There's an increase in train capacity at the moment, and with climate changes adding a stress to the network. Okay, so across the 20,000 miles of track, the biggest challenge is that most of the assets are in a remote location, and especially in the south. A lot of these cuttings and embankments are very steep in comparison to their current design. So I believe most motorways or new rail links or cuttings are built at about 18% versus the 40% seen in the south. Climate change climate change is increasing the weather, the severity of the weather, and that's impacting on these embankments or cuttings, earthworks. Especially in areas to the south where a lot of the geology, like clay, is prone to failure with expansion and shrinking.
Yeah, on top of that, like really deep Victorian cuttings that makes it hard to either access or makes it more prone to accidents. So not difficult environment to potentially monitor.
Yeah. So with remote condition monitoring, it allows us to observe multiple sites. Given that there's 20,000 miles of track, you can't be everywhere to monitor. So having the ability to do monitoring of multiple assets remotely gives us the opportunity to monitor more 24/7, 365 days a year. It gives us the ability to detect early failures, as seen here at Barnhurst, that could result in disruptions or potential loss of life. It also has us the ability to do proactive monitoring. So in areas where they may be planning to do repair works in, say, 5 years' time, if they are monitoring or actively monitoring that area, perhaps repairs may have to be taken sooner as they better understand the earthworks themselves. And then the final point is it can help us kind of assess post-repair designs to see if the earthworks are behaving as intended.
Yeah. So like, and one of the key points and the reason why wireless technology is obviously deployed on this large project, these large areas, is that because you can both do well, a reactive monitoring of areas that are failing, like potentially in Barnhurst or other sites where you know that you have potential failure and therefore potential risk of the traffic. But most importantly, it's also about the proactive monitoring. That's quite important, and that's what wireless technology can allow you to do with a cost-effective technology that you can deploy quite easily across large areas. Moving on to high-speed 2, famous high-speed 2 in the UK.
Yep. So obviously most people here, I'm sure, know the sheer size of high-speed 2. It's Europe's largest high-speed project at this time, and there's a huge diverse array of infrastructure to be monitored, whether that be tunneling, viaducts, station construction, earthworks and bridges. They occur in both rural and urban environments, so dense and sparse monitoring requirements require different monitoring platforms.
Yeah, quite different environments, different actors as well to deal with across the route.
Okay, so why is HS2 a challenge? Well, the route runs along some of the UK's most important infrastructure routes, whether that be the West Main Line or the M6. So data needs to be reliable and constantly available. There are also multiple asset owners and contractors. I believe it's split into 9. There's 9 monitoring or 9 zones on HS2 with the main works, but there were lots more previously with the enabling works. And obviously, a lot of this infrastructure cannot be accessed frequently using traditional methods.
Yeah, so the different environments and yeah, quite a lot of challenges depending on where you are and with different sections.
Okay, so as previously stated here, the project split into multiple sites, numerous asset owners and contractors, and it's alongside the critical routes. Here, for an example, this is Bromford Viaduct over in Birmingham, where we have strain gauges, tilt meters, and crack sensors along the viaduct itself, and we're monitoring that, and that is very different as Highways England. That is very different to Curzon Street, which was previous. Which is, say, tilt meters on the track and tilt meters on the retaining walls, which is a network rail asset. And then finally, to conclude, how Senceive can help. Obviously, we have different sensors and connectivity platforms that allow for monitoring of all types in all types of environments, whether that be urban or rural. It allows for the continual construction alongside critical infrastructure routes, whereas accessing, say, Highways England property or Network Rail property may be harder to achieve over the lifespan of this. I believe it's 10 years. They're saying 10 years construction, 10 to 15 years construction for this project. So having that remote wireless monitoring gives us the ability to monitor long term without having to disrupt these infrastructure routes. And it offers a one system, one turnkey to all zones across this route.
Yeah, key point here. I think it's probably the flexibility of our system, both when it comes to the applications, the actual technology, as Callum said. Yeah, different sensors that can apply to different types of applications. But on top of that, yeah, the flexibility to work with every actor. Either it's one actor that stays for a long time on one section, or changing actors through the length of the project. So really, yeah, the flexibility of the wireless system makes it one of the best tools really to use on this application and on this type of large projects. So yeah, that's it for the UK examples. As you can see, quite a mature market. Again, if we look back at the first part and the legacy of projects like Crossrail, shows that the UK has really made an effort to accept wireless technology as part of specifications requirements on these capital projects, because it's already experienced the benefits of using this technology on this type of sites. So now let's look at Europe, where things have been maybe a bit slower to take off, but where the main focus has been to adapt existing process, simplify this existing procedures, and make sure that they're building on existing expertise really. So the first project that we wanted to present is the Grand Paris Express. This is a huge project, one of the biggest, if not the biggest in Europe. You have 68 new stations being built, several kilometers of additional track, and on top of that, you have the difference between new lines being built, new tunnels, existing line being extended, new station added to your setup. So a mix of different sections that technology needs to adapt to. So the challenges really when it comes to the Grand Paris, well, similar to what we've seen in the UK, multiple applications, multiple authorities, different timelines as well. It's a project that extends over several years. So you have to take that into account when you pick the technology that you choose for one or multiple sections, and the possibility to reuse this technology over time. But the final challenge that has been true for everyone, but especially on this project that have been going on for a couple of years, is COVID-19. How do you work when you're not able to send as many resources on site, when people are stuck at home, or when it is a bit more difficult to access a project? So how can wireless technology help with that? Well, key point here to remember is that wireless technology and Senceive wireless technology can adapt to the current project requirements or the ongoing project requirements through improvements that you can put in place. If we look back at the example that I show in these slides, this one, you're looking at the Saint-Ouen new station, and here the main improvement is looking at how to do prop monitoring with wireless technology. Where before we would have probably had wired strain gauges, maybe heavy data loggers, or simply like manual survey to check these elements. Well, Senceive, through different partners in the industry, has provided what we call smart props that monitors the different load and the deformation of the prop to get a more intelligent understanding of what's happening in your excavation. If you go back one time, SNCF on around this project also accepted Senceive technology has a viable solution to monitor track geometry when it comes to cant, twist, longitudinal profile. The use of wireless technology and Senceive reliable wireless technology allows the different actors on this project to monitor railways in a better way, an improved way. And finally, when you look at tunnels, the use of tilt sensors or laser sensors instead of standard manual or automated survey can provide a cost-effective solution, an easier to install solution in older railways, like here with the RATP in France. So here, the use of GEO1 tilt sensors across this tunnel, monitoring different sections while they're building a new tramway line on top of it. So here, yeah, key point is you have the ability to adapt your project requirements with wireless technology, thinking about new ways to improve the data that you can get out of it. Now, moving on to the second capital project that we want to focus on in Europe, which is the Mediterranean corridor. The part that we are looking at right now is what's called the door to Europe on the north east of Spain in Catalonia. Our technology has allowed different actors to monitor multiple tunnels in this region. That is really a funnel for the Spanish trains that want to reach Europe and different EU countries after that. To give you a little bit of perspective, in this specific area, there is up to 1,500 trains a week, so very much a bottleneck for the circulation. And that means that when it comes to monitoring, obviously, well, you have quite a lot of challenges. You have multiple sites because, as I said, multiple tunnels and multiple structures across a large areas. You have a constrained installation window because the Mediterranean corridor does not only involve these tunnels, it also involves new train tracks, electrification, new train gauges. So you have to make sure that your monitoring program fit with the existing schedule. And on top of that, well, you have an important level of concurrent work, meaning that, yeah, a lot of activity right next to each other. Obviously, you have monitoring that is important to you, but you might have shortcreting in one of the tunnel, or you'll have people releveling the ballast in another section at the same time as you're trying to retrieve important data for your project. So what can wireless technology and Senceive wireless technology can bring to this type of project? Well, the main objective and main advantage is that it can allow you to obtain reliable data in this difficult environment, in this busy environment, in this challenging environment, with sensors like the laser sensor, optical displacement sensors. You can position them in a tunnel, for example, to monitor the convergence of this tunnel, where, well, on this picture, you have easy line of sight, but well, most of the time you might have trucks, you might have people standing in front of it, and therefore longitudinal line of sight might not be ideal for an automated or manual toll station inside this space. So it gives you the flexibility and the reliability of obtaining better data with an easier set of installation, and can be completed with this type of tilt beams that you have right here, longitudinal tilt beams that can provide additional differential settlement information on specific joints of the tunnel or specific parts of the tunnel that needs to be checked for stability. So here, yeah, reliable data in different difficult environments. Same thing here. Tunnel, again, ODS sensors monitoring the convergence, but think about yeah, having a lot of activity, a lot of people passing around, moving things and working. As you can see here, a lot of dust as well, potential difficult connection in a deep cutting, and therefore the wireless solution making it easy to retrieve the data back to your office without having to go back to this type of site. So that's the main advantage on this project. Now, final example for the European capital project is the Anse du Portier. A huge project in the south of France, in Monaco, exactly. 60,000 square meters of land reclamation, as you can see right here. Yeah, very clear what they're trying to do, build new square meter to put very expensive apartments, hotels, and new shops in Monaco. 630,000 meter cubes of dredging, so potential huge impact on the seafront of Monaco, as well as implementing 18 concrete caissons of 10,000 tons each and 1,100 piles. So huge activity, potential huge geotechnical impact and structural on the adjacent structures. So if we look at the actual challenges, well, obviously it's a high-profile project. Everyone knows Monaco. Everyone knows how expensive it is. But on top of that, well, there is the harsh seafront environment that you have to face. Mediterranean Sea is beautiful, especially when it's sunny, but you have the same problem with corrosion. You have the same problem as wind chaps. You have the same problem as humidity over time and strong sun during the summer. So you have to make sure that you have a reliable technology. You have a mix between public space because it's very touristy, because you have a lot of circulation, because you have the Formula One track that I'll show you in a second, but it's also a mix with difficult access. So best way to show you what we're monitoring is to give it to you through the eyes of Charles Leclerc during his last lap this year. So if we follow him right here, and after this turn, the first stop that we'll make is right here. As you can see, the viaduct that we have on the back, we have positioned tilt sensors to monitor the stability of this viaduct at different piers, but also on the deck as well. Now, if we continue up here, you have the site on the back behind this hoarding, just to give you a little bit of perspective. I'm not sure if these workers right here work there, but that's where the site is, so very close to this structure. On the left and on the right, you have an underground parking that is being built. So obviously sensors monitoring the stability of the excavation. And if we continue a little bit further, right here, you can see the famous Monaco tunnel. And here what we were monitoring under this hotel was the stability of the beams and the columns supporting the hotel over the Mediterranean Sea. So when we go back to the different challenges, as we said, harsh environment because the sea is right here on the left. Public space because people can access this area quite easily, so you don't want your equipment to be stolen or impacted, and potential difficult access because on an elevated highway or on a famous hotel, you cannot go send people every other day. So these are the challenges. Hopefully, thanks to Charles, you understand a little bit better what we're facing. Now, if we move to the next slide, giving you a little bit overview of what the wireless technology can do for this project. Well, the real point here is that, yes, you rely on a good technology. Senceive technology has been proven through the years, but on top of that, you rely on great expertise, local expertise. And that's what you want to do with the wireless technology. Either it's with yourself or with partners. The technology is as good as the people that use it. On this project, there is a great collaboration between Senceive, obviously, but a French distributor, GeoMesure, that knew the market, that knew the best actors around this place, and that could introduce the technology and train people on site to use it properly. And finally, the surveying company, the surveying company that was using the sensors themselves on the hotel himself, on the elevated highway, on the underground parking lot. These people knew the local requirements. They knew what they had to do to make to answer the specifications of the site, and working together as a team, made sure that yes, we were taking full advantage of a great technology that Senceive can use. So as a conclusion, I think when you look at the advantages that the Senceive technology and wireless technology can bring to you, obviously that's down to the project, how it can help to protect your assets, your investments, reduce the whole life monitoring cost of your project, of your solution, and keep people safe. But it's also as good as your team is. Either you, the collaboration that you can have with other actors in your sectors, the manufacturers, your distributors, the people that can help you. And Senceive really thrive doing that by helping you before a project, during a project, with our business development team and support team. So hopefully that's one of the takeaway point that you can take today. And that's it for the presentation. We've been 37 minutes long, so that leaves us a bit of time for questions. So for the ones that are not familiar with GoToWebinar, you have the ability to ask a couple of questions on your panel. So feel free to type them on your left screen. You can click on the left and ask us really anything you want about either these projects, the technology, or the general benefits of using wireless technology on your sites. We'll wait a few seconds until people start answering. Okay, I have one that already popped up. I think that's about the Monaco project. How many sensors did you use? What type of sensors? Well, that's an easy one. We had over the different sections, I think we had around like 100 sensors all together, mostly tilt sensors and laser sensors. The tilt sensors on the beam. So actually, we can probably go back to go back to it. The tilt sensors on the beams of the hotel and within the tunnel that I showed you, and laser sensors mostly to monitor the excavation, so to monitor the convergence within the new parking lot that was being built in this area. Any other questions? I'm just making sure I'm seeing them correctly. Callum, do you see anyone? You mentioned Geo1 and flat mesh. Can you explain what they are and how they're different? Yeah, sure. We went a bit quickly on this one. So Geo1 is our long range platform. Wireless platform, point-to-point platform. It relies on LoRa technology, which means that through 800 or 900 megahertz, you can connect to sensors a lot further away or across or through different structures. So it is good for very large size projects. If you think about it, over several blocks maybe of a project, or if you think about a large mine, that's quite useful. The drawback of that is that you'll have potentially lower reporting than with the flat mesh gateway. Flat mesh gateway being a mesh network where you have connections between all the sensors, and using the 2.4 gigahertz frequency, you can have a lot more information going through the system. Therefore, you can achieve higher frequencies, higher reporting rate, and potentially get a lot more information on your projects. And another question. What is battery life for typical tilt meter sensor? Do you want to answer this one, Callum?
Yeah, so the typical battery life for our sensors is 12 to 15 years at a 30-minute interval rate, and that's our flat mesh system. Yeah.
Perfect. Yeah, we have different different types. We have the nano range that is a little bit smaller, more discrete, but gives you the ability to potentially target historical sites or site in the public space where you need to have like a smaller sensor to blend in the environment. So yeah, that's a possibility. Let's go to the other one. Oh, that's piling up. I missed this one. Will you be making the data from the sensor available in real time? So it's always a little bit hard to define real time, but we've done applications in the past where, especially our flat mesh network could be connected to, let's say, USB gateways connected to a laptop. So usually it's not Senceive role to do that. We provide the kit, we provide the equipment that can do it, but it's the role of a monitoring company, a monitoring expert, an engineering firm that can show this data real time to your project, to the actors on site. So if we take the example of a grouting project, or yeah, where we need to have this data live and potential alerts show to you, yeah, we'll leave that to our clients to show that and to put the triggers for yourself. But we have the ability to do that, especially with the faster flat mesh platform. Can sensors be connected to a third-party LoRa gateway? Not at this time. At the moment, we rely mainly on our J1 application and range. We have different type of gateways that can fit better your site, but at this point in time, our J1 nodes or J1 sensors only connect to Senceive gateways. Next question. Sorry, I'm having a little bit of hard time to slide. The ODS sensors give a point-wise information. Have you compared the results with laser scanner to see differences? So actually, we've compared, the laser to toll stations, to other lasers are obviously available on the market. And the reason we've selected the module that we integrate in our sensors is because it's the best that we could find in the industry. So one thing that you have to make sure you understand is that the ODS gives you only one vector between a wall, between a surface, and the sensor itself. It's not a mini toll station. It's not a scanner. So you really get one point, as you said in the question. You only get one point, and the convergence between this point, between your node and this point on the surface. So it's important to understand that when you're putting that in place, for example, in a tunnel convergence environment or a retaining wall that you want to see progress, that's the data that you're getting. But to give you a good idea of our capabilities, I think in terms of resolution, we're at 0.15 millimeter. In terms of repeatability, 0.01 millimeter. In terms of range, anything under 50 meters, if you have a flat surface, like a flat concrete surface or a flat metal surface, you would probably be able to achieve it without any reflector. If you want to push it further, at this stage, we would probably recommend you to use some sort of reflective target because the signal might get a little weak. But we've seen applications from our clients on bridges, especially, or on large abutment projects where we've easily reached 70 meters, 80 meters without any sort of problem. Next one, sorry, I jumped too far. Can you give a difference in cost in percentage between conventional toll station monitoring and these sensors monitoring? I have to say I honestly can't, because it will really depend on the number of sensors that you'll put and the use that you'll have for them. If you're looking at a simple retaining wall, I'm not actually saying that the tilt sensors or our sensor will always be the best solution. If we're being very honest, sometimes the toll station will be the best solution by far, because it will give you 3D absolute movement compared to relative movement. But that's part of our expertise. Callum, myself, the business development team, from our experience in the monitoring industry, we're able to tell you, well, here, it makes sense to put more sensors to get continuous data, to get a better understanding of what's happening. But sometimes we'll just be, no, actually, you're better off bidding with a toll station or another technology, because we want you to win your project. So that's part of our role. But if you have a project in mind, if you have some volumes in mind, please contact us at the end of this presentation, and we can look at it together. Next one. Great presentation, thank you. These are all large-scale projects. If I'm doing work on a singular building, can I expect the same result with less sensors compared to this flagship project? Yeah, 100%. And actually, Senceive thrive delivering technology for both extremely large projects, but also a lot of small projects, especially when it comes to our distributors in different regions. They work, as I said, with surveyors, small engineering companies that will look after a small retaining wall, maybe a small building, a church here and there, that involves 10, 20 sensors maximum, and not the 1,000 sensors that you've seen on this presentation. So obviously, it's good to see the progress that these capital projects have helped us to go through. But when it comes to small projects, we'll have the same expertise, you'll have the same quality of data, and very often you can get great results with 5, 10 sensors combined with maybe a manual survey or something like this. Can you reuse sensors that have been used before? Callum, do you want to take this one?
Yes, that's the answer. Absolutely, you can. We configure the sensors to their specific projects. upon completion of that project, we can reconfigure them to be used on the next project that you have, and that could be the change from, say, just 10 tilt meters that were on your first project, and say the next project requires the tilt meters and some new optical displacement sensors. We can configure both of them to work together on the new project.
Perfect.
Thank you very much.
There you go. So yeah, feel free to use them over and over and over. I mean, we do like to provide the new innovations, the new sensors. But once you have the sensors, what we usually say, yeah, it's a long-term investment. Once you have one project on rail, on this retaining wall, well, you can repeat that as often as you want. And as Callum said before, the battery life can go up to 14 years with the standard tilt sensors. So yeah, make sure you take a full advantage of that. Are you going to design a mobile app instead of web monitor? So I guess you've used web monitor before. The reality is that at the moment and for the past few years, Senceive has never focused on the application on the side of web monitor as one of the main tool of our solution, because on one side you have very expert users that provide much better visualization tools that we will ever do. When you look at collaboration between different types of technology, adding 3D survey with, I don't know, LiDAR, with weather data with Senceive, they will do that really well with third-party or internal platforms that they will provide you on top of their services. Senceive Web Monitor has two main objectives. One, control your sensors. So when you set them up, when you install them, you have the ability to change their parameters. Two, it is to make sure that your system is healthy. So check on the battery levels, check on the connectivity, check on this, on these health parameters of your system, and make sure that it works correctly. After that, we have visualization capabilities, we have alerts capabilities, but it's not the main part of our solution. Really, we focus on making your project work, and after that, we give you the flexibility through FTP transfer, API transfer, to integrate this data wherever you want. Either it's an Excel spreadsheet or the most advanced 3D platform. So hopefully that answers the question. But at this stage, at least, no fancy app to be developed by Senceive. Good presentation, gents. I like your configuration tool on your website. Good tool. Yeah, if you haven't been on our website, please check Senceive.com. It can be quite helpful if you're not looking for a specific product, but just understand how you can answer the questions about a specific application. So you have the ability to search, for embankment applications or maybe tunnel applications, and see which sensors relate to each of them. So feel free to check that. We also have quite a lot of case studies. So if you want more ideas about what can be done with the technology, if the presentation was not enough, please go on our website, check it out, and come back to us with more questions. Emma, great presentation, guys. Thank you, Emma. I think this one is for you, Callum, more so. Yeah. Do the sensor have to be physically returned to you to be reconfigured, or can the end user do the reconfiguring between projects? No, you can do the reconfiguring. That's part of it. Obviously, on the first project, either Senceive or the distributor will make sure that you're fully trained, that you have all the knowledge necessary to do that yourself. But no, you have the ability to obviously change any parameter on your system. Either it's the simple ones like frequency, like the naming, their position on the site, these sort of things, or the more advanced one if you want to set up, as I said, alerts, or if you want to set up FTP transfer. It's all about knowledge, and it's all about training, and that's where Senceive can help, or distributors can help to train you on this and make sure that you have all the tools to make it work correctly. For slope monitoring, what is the optimal distance between the nodes to give a proper monitoring system using the flat mesh system? Yeah, so first point, and you're completely right, using flat mesh is highly recommended on slope monitoring, and just because, well, these are critical assets. Callum presented what we're doing with Network Rail at the moment. Thousands of sensors deployed everywhere. But in terms of distances, from the top of my head, we usually recommend to have one sensor every 3 meters. I mean, the closer the better, if we're being honest, especially in critical areas where you might have a slope here and not 2 meters away. You want to make sure that one or multiple sensors will detect that, and the other will show stability to really pinpoint the area where you issue is happening. But after, it really depends on your knowledge of your site, the geology, the actual risk. Are you on top of a railway, or are you on top of nothing? That will probably decide for you how much you want to spend, how many sensors you want to put, and how much information is useful to you and the people on site. If you have more questions though on landslides activity, especially if you're based in the UK, I would probably suggest, yeah, you contact Callum. Definitely, he has a ton of projects that he can chat about in more detail, and he can scope you easily a solution based on your requirements. And I think we're getting at the end of it. Oh no, sorry, an extra one. Thanks for excellent presentation. Thank you. Very nice to see Senceive doing well. Well, sensing is a huge future. Infrastructure and construction will be transformed by having smarter monitoring information such as this. And thank you, Robert. Robert, couldn't say it better. That's a great conclusion. Yeah, as we said, and hopefully the presentation show that. Yeah, wireless technology is already part of a monitoring system of requirements in Europe, but across the world. So if you have opportunities, if you know that you can make a difference with this technology, please contact us. You'll have our addresses right here in the end. Otherwise, I'm sure you can find us around. And yeah, on this note, I think, Callum, we can conclude. Say bye to everyone.
Thank you very much, guys. I appreciate your time. Thank you.
Thanks a lot, guys. Have a great day, and see you soon.